Hello, this is Joseph Sotrano. I'm here to share with you carbon fiber laminated with TPU film application. It's something we've been working on for the last couple of years. Satnus Dallas had the lead with the technology application, and I've been working this from a commercial point of view for that time as well. We believe it's an exciting application, and we look forward to sharing it with you. Talk through the agenda. First, we're going to do a brief introduction on what thermoplastic urethane is. We're going to talk a little bit about carbon fiber, the growing market, kind of understand where it is now and where it's going forward. How TPU can bring value to carbon fiber laminate applications, and talk through two of the specific applications we have. One is the exposed weave. It's where you can see the carbon fiber weaved into each other. This is what most people are familiar with. You see it on vehicles, in bike helmets, different kinds of applications. Also, then finally, we have another application, and this is using unidirectional carbon fiber. This is actually most of the carbon fiber used out there. You don't see it because it's often painted or covered in some way to protect the underlying fibers. But again, this is another place where TPU can be useful. So what is TPU? TPU basically is made of three distinct chemistries or chemicals, diocyanate, a polyol, and chain extender. We can basically change these different materials. It gives a high number of permutations of different types of TPUs. In addition to also changing the kind of chemistry, we also can do things such as change the ratio of the hard segment to the soft segment. That kind of gives a really big range of TPU from a very soft, tacky adhesive down in the 50 something Chauray range all the way up to like a structural plastic such as isoplast up in the 82 or slightly 82D or slightly above range. So it becomes a very diversified material. Uh, Thermoplastic polyurethane is not just one chemistry, it's just defined by the urethane bond and is several different chemistries. Here are the main polyol chemistries in a lot of way that TPU is referred to. You have polyester, polyether, which are probably 75 to 80% of the TPUs that Lubrizol produces. But we also have polycaprolactone, or also called polycaps, and a few specially polycarbonate-based chemistries. These different chemistries have their strengths and weaknesses. For example, polyesters are really good for chemical and petrochemical resistance, where polyethers have good chemical resistance, maybe not as good as polyester, but also have very good low temperature flexibility. We have TPUs that are ductile down to minus 40 C, maybe even below that. Also has good hydrolytic stability and some improved UV and fungal resistance. Polycaps are kind of somewhere in the middle, giving you the most of best worlds. And polycarbonate is a few specialty grades that we have that target high temperature applications. Not only do we have different polyesters, polyethers, polycaps, and polycarbonate TPUs, there's also another family, if you will, called aliphatic versus aromatic. The real key difference is the UV performance of aliphatic materials. You can see in some further on slides when we talk about it, they're very good at staying clear, non-yellowing with UV sun, as well as also having some of the typical TPU properties such as abrasion resistance, tear resistance, puncture resistance, and so on. Really, the main difference in chemistry is that in an aliphatic TPU, the benzene ring is fully populated with hydrogen. And then now we discuss aromatic TPUs. These are a bulk of the TPU grades out there. They will the workhorses, if you will. They have very good chemical resistance, abrasion and puncture as you'd expect TPUs to have. They the challenge with aromatic TPUs, or can be depending on the application, is that they will yellow with exposure to UV light. If they're colored blue or green, you will see the color shift over time. One slide we always like to share when we're talking about TPU is the abrasion resistance as one of the main reasons to choose TPU. As you can see from this slide, this is a Tabor abrasion test. Small bar is good. It means that you have little weight loss. Big bar is not as good. And as you can see all the way on the left, TPU has a very, very low abrasion loss in the Tabor abrasion test. It's probably 4 times or more better than nylon 11. So it is very, very good for wear applications. Talking a little bit, as I mentioned before, our ALR series of TPU. This is our talking again about our ALR series of TPU. This is our one of our aliphatic lines of TPU. You can see some of the testing we've done as far as the delta YI and the color index and gloss with exposure to UV light. So this particular test is equivalent to 3 years in the Florida weather. It's per ASTM G90. And you can see that if you start all the way on the left-hand slide where you go delta YI, there is a slight increase and then fall back in YI measurement. However, you need to consider that a YI change of less than 8 is not perceptible by the human eye. So this little bit of change will really be imperceptible in the application, and the material will still remain non-yellow and clear. Same thing with the color index. You can see that you get a rise to just over 1 during the cycle. But again, people cannot discern that color change unless it goes above 2. So again, you're still going to get a material when exposed to UV that remains clear and not yellow or not colored. Okay, moving on to the next slide. One of the main applications for this film is basically paint protection. You can see it's made up of 3 different layers. The bottom is a PSA or a pressure sensitive adhesive. You have a soft layer of TPU that makes it pliable and allows it to adhere to contours and curves. And you have a hard coat, which is typically up there, or a top coat, which is typically up there for chemical resistance and for protection for the underlying elements. This is an application that Lubrizol has been working with for decades. We have, years and years of experience of our Lubrizol resin on vehicles in the field, non-yellowing and lasting for a decade or more. Talking a little bit about the carbon fiber composite market, the CAGR of this market is estimated to be 10 to 12%. This data is a snapshot and taken in 2015, but if you had looked at the actual data between that time and currently, we're slightly ahead of the overall forecast in this chart. We expect to have some additional estimates here in the next little bit, but it is safe to say that the carbon fiber trend and overall composite trends in the marketplace is still going strong with double-digit growth. So why are these so popular? So why carbon fiber laminates? The main point is it has a very high strength to weight ratio. And that is extremely important for an automotive and other areas where weight is a key and strength is also a key. There's one area study that says if you have a 30% reduction in body weight, you'll save 3.5 gallons per 100 miles. So using these as strength members in vehicles, in other types of applications, can certainly bring down the weight of the vehicle, which can then help the vehicle manufacturer hit their fuel standards. Talk a little bit about how you make carbon fiber. Step 1, you're basically pushing off everything else and leaving carbon fiber filaments behind. And then you basically take those filaments, and into step 2, you weave them into a fabric. And here you have a carbon fiber fabric picture in step 2. And then you take that carbon fiber and you soak it in a heat curable pre-preg material. So this material basically will cure as you get heat and temperature applied to it, making it a rigid, from taking it from a pliable fabric to a rigid part. Then you take this material, the carbon fiber weave, along with the pre-preg chemistry, and you lay it out into your part, as you can see the ladies doing in step 4. You put them down, you get them in the shape, and you use multiple layers depending on the strength required for the overall part. Once these carbon fiber elements are laid out, they're then put into an autoclave and they're heated, and the pre-preg cures, basically then becoming a stiff part. Once you take that material and you have that part, you can see in step 6 all of the things that you need to do to get that part out into the field. You have to put a primer on, a base coat, a clear coat, basically to protect it from the elements, to protect the underlying carbon fiber matrix from UV light. So it is quite an involved process to make a carbon fiber part. And we're going to talk about specifically how Lubrizol aliphatic film is used in the exposed weave application. Here again is some of the process that we talked about. Really, this is basically if you're going from left to right, we're starting at step 5, where we're in the autoclave or mold process. You basically build them up, you form a carbon fiber laminate, then you put a UV coating for weathering, a clear coating for abrasion and shine, and in some cases, you may do additional clear coats, you buff it, and then you have a part. In the case with TPU film, we can remove the UV coating step and the clear coating for abrasion step. So when you had seen those ladies putting the carbon fiber down inside of the tool, instead of putting the carbon fiber face down on the tool, you'd put a TPU film first and then the carbon fiber behind it. When that goes through the curing process, the TPU film will laminate directly onto the carbon fiber, giving it the scratch, the coating, the UV protection. So it basically takes off a bunch of different steps at the end here. The other interesting part of the carbon fiber market is there doesn't exist that we know of a carbon fiber part maker that will basically go all the way from end to end in their building. So they'll create the part, then they'll have to send that part out for UV coating, clear coat coating, and then it'll have to be shipped back. This adds a significant amount of cost as well as adding supply chain time and complexity. So in this particular step, when you're using TPU as the underlying film, you can put that film directly in, create the part, and then the carbon fiber part producer can also go ahead and buff that particular part, and they're ready. It completely gets rid of the UV coating and clear coating for abrasion steps. Once you have that TPU on the carbon fiber, the ALRCL film, basically, again, just to repeat, you'll have UV protection, abrasion resistance, shine, non-yellowing, chemical protection, scratch protection, and scuff protection. Again, without having to do all of those extra steps of clear coating and preparation. What I talked about earlier in the beginning is basically a paint-ready TPU. This is using unidirectional carbon fiber. It doesn't look nearly as nice, the carbon fiber itself, as the exposed weave does. It basically looks just like a black, ununiform black surface that is carbon fiber, and they typically take that carbon fiber and prime it and paint it. So in this application, we'll show how TPU film can be used to help remove some of those steps. Process is very similar in using the exposed weave. The key differences here is that with unidirectional, when the part dries, you get little dry lines inside of it. And you can see the little red dot up in the middle upper animation there, where you can actually see you get some of those dry lines. So when you get those dry lines in the particular part, you typically have to have a human inspection to where they're looking for the dry lines, reputtying, doing a primer coat, going through the process, 1, 2, 3 times to get a smooth surface so that they're able to then paint the part and have it ready for use. So basically, this gives a lot of human labor, a lot of cost to finding these dry lines, puttying them, smoothing them, sanding them, buffing them, and then finally getting it ready for paint. Now with TPU material, basically can get rid of the primer coat and putty. So your part, again, you put in the TPU film down. The TPU film can be colored. put it down in the tool, the unidirectional carbon fiber behind it, part comes out, primed, and ready for painting. Again, removing a couple of steps from the process. Now, this TPU, as I mentioned, can be colored whatever base color you'd like it to be. A TPU is readily comparable with master batches or can be compounded into color. Typically, you can see grays or whatever color that will look best or underneath the underlying finished paint and clear coat step. So basically the same thing, TPU on the top of the carbon fiber, paint directly on the TPU. Talk a little bit about some of the lab development we had done in Brecksville, Ohio. We had done different levels of prepregs, 2 and 3, different stack ups. We've tried many different films, from a monofilm to a co-extruded soft hard film, to different aromatic films. In these particular tests, as you can see, we did different geometries from curves to sawtooths to see if the film would move and form with the part and give you that clean surface. Again, these samples have piqued OEM interest, and we are in consistent development with getting these out into the field. But there can be other applications as well out there for carbon fiber. Here is some additional results of the carbon fiber. So we did all of the testing for Florida weathering, looking at the gloss, how it heat ages, chemical and abrasion resistance, check physical properties of the carbon fiber, check that the film could be painted. As another item, it's also possible to print a logo on the film. So if you wanted some kind of artwork or something of that nature, it could also be part of the film sitting on top of the carbon fiber. The other thing that we've noticed during this testing is that in some cases, depending on the carbon fiber matrix you choose, the film will increase the impact resistance of the overall product. So if you look down at the bottom right picture where you have the gray and the black, you can see a drop dart test. And you can see on the left, you can see clear through into the black, the uncoated carbon fiber. You can see that the dart basically went through the carbon fiber completely. That same exact height and inch-pound of force basically left a bump or indentation into the carbon fiber with film in the gray, but did not fully go through. You can see from the chart the increase in the impact drop dart test. Additionally, again, depending on the construction, we have seen a modulus increase in the overall construction on the order of about 20 to 25%, which again, if the whole point of using carbon fiber is for strength, if you can make that existing carbon fiber stack up or build up of material stronger, then again, you could further potentially reduce weight. Again, more of that. We're talking about different stack ups of different carbon fiber with modulus. You can see, for example, the yellow bars, as in this particular case, it was an ETE grade, might be a little bit difficult to see on your screen. You can see that the modulus had increased. And then you can also see it with different levels of different kinds of TPU on the carbon fibers. But again, if this is something that is of an interest, it would take a little bit of trial and error to get your carbon fiber stack up or your customer's carbon fiber stack up used with the correct TPU to get that modulus increase. And finally, another application that kind of came as part of this as a spin-off, it's somewhat separate. It's an in-mold film solutions for different molded parts using ABS or acrylic or PC or PC ABS or any plastic that TPU will readily stick to. I'm going to walk you through the top piece here, 1 through 4, on what's happening in the diagram on the top. And the first one, you can see that film would roll in front of the mold, just in the mold on the top. That's step 1. In step 2, you either have an electromatic attraction of the film to the mold, or vacuum can be used to get that film into place. Then step 3, you inject your plastic, close your tool, form the part. When you retract your tool and your part pops out, you now have a plastic part with TPU laminated over the top. And you can see that in some of our pillars or black plastic simulating pillars on the bottom right there, where you can actually see that the ALR TPU is basically over the ABS plastic. In this particular case, the TPU is going to give UV resistance, scratch resistance, but it also glosses up the ABS film to 80 to 90 gloss range. Again, this is, you know, can be replacing a paint process or a hard coating process, or perhaps even a dual shot application to where you're putting something over the ABS to protect it. And another test that we did with this film on this black plastic is a stone metal impact stone test, where basically you're taking a set of stones defined by an SAE standard and you're shooting them at a plaque at 30 to 60 miles an hour. And this is looking to simulate stone and gravel on the roadways. If you look at the plaque on the left, that had no protection, no TPU over the top of it. It gets pretty chipped up, as you might expect from stones at 50 miles an hour. If you look to the right, the TPU gives a very high level of protection from that chipping, as there's only a few on that particular plaque. So again, the TPU is giving impact resistance along with abrasion, UV resistance, chemical resistance, and all the other nice things that TPU can do for the underlying plastic. So to summarize, you know, aliphatic TPU is shown to reduce UV damage, replace clear coats, and basically giving a cost savings for exposure weave application by removing that clear coat type painting that is required to protect the underlying TPU. Aromatic TPUs have been shown to eliminate putting and sanding steps, getting panels ready to be painted and shipped out. Again, saving time from that putting, that sanding, that reiterative process that basically gets a part nice and level, ready for painting. We've extended this application to in mold film applications, to where you could be doing pillars, other mirror black applications, interior applications, places to where the underlying plastic, such as ABS, needs to be protected from scratch, mar, UV, chemical, and so forth. You can print on TPU film. You can either print on the underside or top side to basically give a logo, piece of artwork, whatever you may want to do. We've noticed a significant improvement in physical properties in some different applications with TPU, such as flex modulus and puncture or dart drop tests. And basically, we are currently working with all channels to incorporate TPU with carbon fiber, anywhere from all the way back at the carbon fiber producer to the parts producer down through the end OEM to make this application come to reality. If you have any interest or further questions, please contact me. You can see my email address down below, and I look forward to hearing from you and talking more about this very exciting application.